Okay, so welcome to the Department of Mathematics, IIT Indore. So today is the National Day Science Day of 2022, and this event will be organized. So welcome to the Department of Mathematics, IIT Indore. So today is the so this event will be organized by the student, PhD student of the Department of Mathematics. So from the entire student, they are going to organize. So in that, I request the student coordinator, please take care of the session. Anirudh, are you here?
Yes, sir.
Yes, please take care of the session.
So I think the poster is visible now, right? I was just sharing the poster. So hello, welcome everyone to the celebration of National Science Day. I would request Manasa Bhatt, PhD student, to brief us about what is Science Day and why do we celebrate it. Manasa, over to you.
Okay. Hello, everybody. Science isn't about why, it's about why not. A pleasant good afternoon to all of you who have joined here with us to celebrate this energetic day. We, the mathematicians from the Department of Mathematics, IIT Indore, wholeheartedly welcome you all to this program. Today is a very special day
Excuse
for
me,
all of us.
excuse me, Manasa.
Yes,
We
sir.
are getting a lot of frequency in your voice.
Okay, sir.
Yeah.
Is it fine now, sir?
Yes, it is now fine.
Okay, sir. Okay, yeah. Today is a very special day to all of us because in India, every year we celebrate this day as National Science Day to commemorate the discovery of the Raman effect. Sir Chandrasekhar Venkata Raman, an Indian physicist, announced the discovery of the Raman effect on February 28, 1928, for which he was also awarded the Nobel Prize in Physics in 1930. On this National Science Day, let us all remember this great Indian physicist for his significant and monumental contributions in the field of science. He will remain as an inspiration to all of us. So now I request our HOD, Dr. Neeraj Kumar Shukla sir, to speak a few words about our department. Over to you, sir.
Thank you very much. Thank you very much for this initiative. Actually, I will try to speak in Hindi, not in only English. So, because so many students are from this MP school as well. तो सभी बच्चों को नमस्कार. जैसा कि नेशनल साइंस डे नेशनल साइंस डे क्या है, हम लोग क्यों मनाते हैं, कि उसी में एक स्टेप हम लोग आगे बढ़ते हुए हम सेलिब्रेट कर रहा है. सेलिब्रेट का पर्पज ये है कि आपके पास कुछ हम जो मैथमेटिक्स की चीजें हैं उसको थोड़ा सा एक्सप्लेन करने की कोशिश करें कि कैसे आप रियलाइज कर सकते हैं ना, ज्योमेट्रिकली कैसे आप देख सकते हैं. हाँ, उसी प्रोसेस को थोड़ा सा आगे बढ़ाने के लिए हमारे जो रिसर्च स्कॉलर्स हैं, अनिरुद्ध, साहिल की दिव्या, ये सब बहुत अच्छा मेहनत करके अंडर द डायरेक्शन ऑफ डॉक्टर शांतनु मन्ना और सेमिनार कमेटी के साथ मेहनत करके एक कुछ लेके आए हैं आपके लिए, कि जो कि आपके लिए काफी यूजफुल होगा. इसको आप अभी देखें या फिर बाद में देखें, ये काफी इंटरेस्टिंग होगा. और थोड़ा सा मैं बताऊं नेशनल साइंस डे, उससे बेटर है कि आप थोड़ा सा गूगल पे सर्च करिएगा कि क्या है, मतलब नेशनल साइंस डे थे आपके सर सीवी रमन कौन थे, वो क्या किस लिए फेमस थे. तो अगर सर्च करिएगा तो आपको मिलेगा, अच्छा सा नॉलेज मिलेगा और उसी बहाने कुछ और कंटेंट मिलेगा कि क्या फिजिक्स क्या होता है, मैथ क्या होता है, क्या रोल है ना. उसी को समझाने की कोशिश हमारे स्टूडेंट कर, बहुत अच्छा काम कर रहे हैं. इन लोगों ने इस तरीके से प्लान किया कि कुछ छोटी छोटी चीजें समझाने की कोशिश अपने ट्रायंगल क्वाड्रिलेटरल कोशिश करेंगे. आप समीकरण जो इक्वेशन बनाते हैं उसके लिए शीतल आपको समझाने की कोशिश करेंगे, साहिल भी आपको लोकस के बारे में, जैसे आपका कोई क्या के बारे में एक्सप्लेन करने की कोशिश कि दिव्या होटल जो है समथिंग कुछ बताने की कोशिश करेंगे. तो हम लोग सुनेंगे इसको, आप लोग सुनिए इसको और अपने और दोस्तों के पास और इसको इस लिंक को भेजिए, कोई इसको देखें और उससे कुछ नॉलेज गेन करें। केवल इतना ही नहीं, आपके जो YouTube चल रहा है, YouTube में एक लाइव चैट का भी है, वहां पे आप अपना क्वेश्चन, यू कैन पुट योर क्वेश्चन एंड द स्टूडेंट्स विल ट्राई टू आंसर। ओके, तो बहुत अच्छा है, गुड इनिशिएटिव बाय दिस आवर रिसर्च स्कॉलर। ओके, सो थैंक यू वेरी मच। हेलो।
Thank you, sir. Thank you, sir, for your wonderful words. So, apart from remembering the great scientists and their significant contributions, the spreading this message of importance and application of science forms a core objective of this day. So, today, like the Department of Mathematics, thereby brings in the various demonstrations of math concepts using some physical models and softwares. We really hope that you people will all enjoy and learn from these demonstrations. So, to begin with, we have Mr. Anirudh Deshmukh, who is going to like say you something on elementary geometry by using some physical models. Please enjoy the session.
Is the voice there or voice is not there?
Voice is not there, Anirudh.
Oh, voice is not there.
Yeah.
Just a minute.
In sharing option, there is a optimize with video. So you have to just click on that optimize for motion and video. So then you
Oh,
you are
okay,
able to
okay.
hear you.
This one. Action and video. Okay, what about now? Is it there? Still not there?
No, audio is not coming. You are doing the same what I
No,
said.
yeah, I did that optimize for motion and video. So do I have to share screen or application? Wait a minute.
Whole screen. You have to just share the whole screen and then.
Okay, wait.
Hello.
Hello.
Yeah, Anirudh.
Yes, so now I have shared this.
So you stop sharing. So then we can maybe try from this side.
Okay.
Yeah, you please stop sharing.
Hello, I am Anirudh Deshmukh, PhD scholar
Hello.
in Department of Mathematics, IIT Indore, and today we will be learning.
Anirudh, please stop
Yes.
sharing.
Oh, I have stopped sharing, sir. Some basic geometry using some models. So, okay, let us begin. We'll be first looking at lines and angles. So,
Is it now audible?
yes, it is audible. So this small segment is going to. Hello, I am Anirudh Deshmukh, PhD scholar at Department of Mathematics, IIT Indore, and today we'll be learning some basic geometry using some models. So, okay, let us begin. We'll be first looking at lines and angles. So this small segment is going to demonstrate lines, and using this, I'll be measuring angles. So yes, there are two ways to measure angles.
Manu sir, actually audio stopped. Maybe I don't know. You're not able to hear.
Hello, sir.
Hello.
We can't hear audio, sir.
Now can you hear me? Hello?
Yes, sir. Yes, sir. Yes, sir. We are, sir.
Okay. So shall we start from the beginning?
Yes, sir.
Yeah, okay.
Hello, I am Anirudh Deshmukh, PhD scholar in Department of Mathematics.
It's audible, sir. It's audible.
Learning some basic geometry using some models. So, okay, let us begin. We'll be first looking at lines and angles. So this small segment is going to demonstrate lines, and using this, I'll be measuring angles. So yes, there are two ways to measure angles. One way is we can go anti-clockwise, and in that case, you'll be measuring angles from the inside. So the measurements are written on the inside, 0, 10, 20, 30, and so on. The other way is to measure angles from the clockwise direction, and in that case, the measurements are written on the outside of the disk. So it is 0, 10, 20, 30, and so on. So these two are parallel lines, and we are going to measure angles from this transversal. There are 4 different angles that are made. So these two are called alternating angles, and these two are called corresponding angles. So we are going to see the properties of those. So let us first measure this angle. So this is about 90 degrees here, and if I go here, then it starts at around 180 and it goes up to 270. So that is again 90 degrees. So we see that alternating angles are equal. Again, if I measure from here, it starts at about 0 and goes up to 90. So these two corresponding angles are also equal. And this is not only true when the angle is 90. So now we have changed the transversal. And even now if we look here, this angle starts at 0 and goes up to say 60. And if we go here, it starts at 180 and goes up to 240. So again, the alternating angles are equal. And similarly, this starts at 0 and goes up to 60. So again, the corresponding angles are equal. So this is the first property that we observe, that the alternating angles and the corresponding angles are always equal. So using 3 segments, we can form a triangle like this. And now if we measure angles between these 3 segments, so let us measure here. It starts from 0, goes up to 60, so it is 60 degree. If let us measure here, it starts from 0 and again goes up to 60 degree. So this is also 60 degree. And here also it starts from 0 and goes up to 60 degree. So if we add these 3, then it is 180 degrees. So I have changed the triangle, and this triangle is called a right angle triangle, because if we see here, this is a 90 degree. It starts from 0 and goes up to 90. But what about the other 2 angles? Let us measure them. One starts from 0 and goes up to 40 degree. The other starts from 0 and goes up to 50 degree. So what are all the angles? 40, 50 and 90. If we add them up, we again get 180 degrees. So this is called the angle sum property of triangles, that you take any triangle, always the sum of the angles of a triangle is 180 degrees. Using 4 sides, we can make a quadrilateral. And again, we are going to observe the angle sum property of quadrilaterals. So let us start measuring angles. Here it goes from 0 to 70. So it is 70 degrees. Here it goes from 0 to 110. So it is 180 degrees. Here it again goes from 0 to 70. And this one again goes from 0 to 110. So these two form 180, these two form 180. So all 4 together give us 360. So this is true for all quadrilaterals, and this is called the angle sum property of quadrilaterals. So this was a special quadrilateral. It is called a parallelogram because the opposite sides are parallel. And moreover, if we see, the opposite angles are equal. So we are going to see some special properties of this parallelogram, and we'll use this to find the area of different shapes. Now we want to find the area of this parallelogram, which has one side as denoting it by B. So how to do it? So right now we don't have any other way of measuring the area. But what we can do is, we can remove a triangle and place it very nicely so that this parallelogram will become a rectangle. So let us remove this triangle and let us place it very nicely. But where to place it? Here it doesn't form a rectangle. Here also it doesn't form a rectangle. But I observe that if I place it here, now it looks like a rectangle. Now that we have formed a rectangle, we know how to measure its area. The area of a rectangle is the length side into the breadth side. So this length we had already denoted it by B, and the other length now I am denoting it by H. So the area of this rectangle is B into H. But how was this rectangle formed? It was actually formed by placing this triangle here, which actually was our original parallelogram. So therefore, we have something like this. So we had a parallelogram with base B and height H. So the area of this parallelogram is B into H. Now we want to measure the area of this triangle, but we have not seen how to do that. What we have seen is how to measure area of a parallelogram. So let us try to make this into a parallelogram. First, what I'll do is I'll separate this triangle into two different triangles. These are two triangles, and now I will duplicate them. So I'll bring two triangles which are exactly the same. As you can see, they fit very nicely, and I'll use this to form a parallelogram. What I will do, I will fit this here. I'll fit this here, and I'll fit this here. Now this is a parallelogram, and I know how to measure this area. So we have found this parallelogram, and we know that the area is P into H, where P is length of one of the sides and H is the height. But this parallelogram is made of two triangles which are exactly the same. So these two triangles which are exactly the same. So each of this must cover half of the parallelogram, and therefore the area of the initial triangle must be half times B times H. So now let us look at a rhombus. So rhombus is a quadrilateral whose all sides are of equal length, and again we want to find its area. So this is a typical example of a rhombus. What I am going to do is I am going to fill this up with some triangles. So this is the first triangle, second triangle, this is a third triangle, and this is the fourth triangle. Now I want to duplicate it. So I'm going to fit again the same triangles, but in such a way that I can get a rectangle or a parallelogram, because I know how to measure their areas. So let us take these two, let us put these here, let us take these two, and let us put them here. So if I merge all of these, now this looks like a very nice rectangle. Now that we have this rectangle, we know what is its area. So let us name one of the sides as D1, the other side as D2. So the area is going to be D1 times D2. But what are these D1 and D2? If we look at this rhombus, then D1 is length of one of its diagonals and D2 is length of the other diagonals. But we cannot say that the area of rhombus is directly D1 times D2, because there are these extra areas which are remaining. And what are these extra areas? They are precisely the area of this rhombus again, because these blue triangles were just the duplicates of the green ones. So 2 times the area of the original rhombus is D1 times D2, and therefore the area of the rhombus is half of the product of diagonals. So we are again going to use a parallelogram to find the area of a circle. So let us start with a circle of radius r, and what we do know is its length is 2 times pi times r. So how to find its area? First I am going to sort of fill this up with these segments. So now I have filled this circle up with these segments, and now I'm going to take these segments and make them into a parallelogram. So how to do that? So I'll take one segment and then put the other segment in the opposite way, and the third segment as the first one, and fourth segment in the opposite way. So now we have filled all these segments into a parallelogram, and now we want to find the length of one of its sides. So what do we know is that all these smaller arcs, they form the length of the circle, which was 2 pi r. So this side and this side together form 2 pi r, so one of them has to be pi times r. Now what is the height of this? If I start from this point and go up to this arc, this is going to be r. So the height is r, and one of its sides it's pi times r. So the area will be pi r into r, which is pi r square. And this is exactly the area of the circle.
Hello, Anirudh. Anirudh, are you here?
Yes, yes, I am.
Okay. Yeah, please take care of this.
Mhm.
So,
So,
may
are there any
yes.
questions from the audience in this? On YouTube, I see there is no question.
So maybe some of the participants they are not that much capable on English. So could you kindly little bit explain about in Hindi about your presentation, please?
यस यस तो हमने किया क्या है कि एक बेसिक शेप है हमारे पास जिसे हम पैरेललोग्राम बोलते हैं। क्यों उसे पैरेललोग्राम कहते हैं? क्योंकि उसके अगर अपोजिट साइड्स हम देखें तो वो पैरेलल लाइन से बनते हैं और उसके अपोजिट एंगल्स इक्वल हो जाते हैं, क्योंकि हमने अभी शुरू में अल्टरनेट एंगल्स और करस्पॉन्डिंग एंगल्स की प्रॉपर्टी देखी। अब वो एक पैरेललोग्राम इतना बेसिक शेप है कि वो बाकी सारे शेप्स का एरिया फाइंड करने में हेल्प करता है। तो हम कोई भी ट्राइंगल, रोम्बस और सर्कल, ये सारे एरियाज जो है जिसका एरिया डायरेक्टली ऐसे मेजर करना मुश्किल है, उसको हम पैरेललोग्राम के थ्रू हम मेजर कर सकते हैं। तो इज इट फाइन सर?
Yes.
I think it would have been better if that last slide was on, but okay, fine.
Okay, thank you, Anirudh.
Okay.
Yeah.
Yeah, Manas sir.
Yes, yes. Hi.
Yeah, with your permission, can we give a round of applause to Anirudh for this?
Yes, yes, please.
Yes.
Okay, so who is going to be next? Sahil? Are you going?
Yeah. No, next one is Sheetal.
Sheetal, okay.
Sheetal sir, yes.
Uh, Thank you, Anirudh, for this wonderful demonstration on elementary geometry. I'm so sure that the students have tried to visualize the basics of visualize these basics of geometry. So, in the next, we have with us Miss Sheetal Wankade, a PhD student from the Department of Mathematics. She is also going to explain us via demonstration the elementary algebra. So, the session is of Sheetal's.
Chital Wankade, and I am PhD scholar in the Department of Mathematics, IIT Indore. And today we will be discussing some elementary algebra using these models. So first we are going to represent some algebra tiles. So here we are going to use these tools. Okay. So first this one, these tiles represent you the x variable. This is actually a rectangle of with 1 and length x. So its length is actually x. So this represent your x tiles. So similarly, this one represent your y tiles because this rectangle with length y and width 1. So using this x tiles and y tiles, we are going to make first x square, xy and y square. So if you see, so this your x tiles of length x. So we are going to make a rectangle whose area is xy. So for that we need this x and this y. So one side is of y length and one side is of x length. So we need to fill this area. So for that we need this 1, 2, 3, 4, 5. Okay. So that means this is your rectangle whose one length is y and one length is x. So the total area is xy. So for that we have these tiles. Okay. So that means this represent your xy. So similarly we make our x square. Okay. So for that we have this tiles of length x. So using that we make a square whose area is x square. So this one, if you see, all the sides are equal with length x. So for that also we have these tiles. So this represent your x square. Now similarly we go for our y square. So this is your, so using that one also we need another side this. So this is also a side of length y. So using these two we are going to make a square whose area is y square. So fill all the area here. Okay. So this is square of area by square. So now we have our tiles. This represent your x square, this represent your xy, and this represent your y square. And similarly, we have this x tiles and this your y tiles, and this represent your 1. So similarly, all the colored sides will take positive, and for that, the white side for all the tiles represent you the negative sides. That means this is your positive x square and this is your negative x square. Similarly for all that. Likewise, your this is your positive one and this represent your negative one. Now we are going to make 0 pairs. So this is your x square and this side white side represent your minus x square. So both of these using this x square and minus x square, we make a 0 pair. That means your x square minus x square make you 0. Similarly, this two also, this is your x and this represent your minus x. So this also gives you a 0 pair. So and similarly for 1, this is your positive 1, this is your negative 1. So this gives you 0 pair. So for 0, we are going to use this kind of pair. Now we see representation of some algebraic equation. So we are going to represent this algebraic equation 3x square with a model. So we have these tiles x square. Okay, so using that one, we are going to make this polynomials 3x square. So that means 3 times of x square. So your 1, 2, and 3. Okay, so they represent you this algebraic equation 3x square. So likewise, we are going to do for this. Similarly, we do for this polynomial minus 2x square minus 3. So as we discussed in starting, this white side represent you the negative side. So this is the tiles of x square. So that means this is your minus x square. And we want this minus 2x square quantity. That means 2 times of this minus x square. So 1 minus x square, 2 minus x square. That makes your minus 2 times of x square. And now we need to make this quantity minus 3. So as this is your plus 1 and this is your negative 1. So 3 times of negative 1 give you minus 3. So we have this 1 minus 1, minus 1 and minus 1. Now they represent you this polynomial minus 2x square minus 3 as you see. Let's see how to find the value of this expression at this value of x equal to minus 3. This is called substitution. So first we are going to make this expression 3x minus 4. So for that we are going to use this slide tiles of x. So we need 3x. That means 3 times of x. So this 1x, 2x, 3x. So that makes your 3x. Now we need minus 4. That means this represents your minus 1. So 4 times of minus 1 gives you minus 4. Now this makes your expression 3x minus 4. So on substituting this value x equal to minus 3, what will be the value of this expression we need to find. So your x is minus 3. So instead of x, we need to substitute x equal to minus 3. So that means instead of these tiles, we are going to use this minus 1, minus 1, minus 1. So that makes your minus 3. Okay. Again, we need to substitute for these tiles. So instead of x, we have this minus 3. Similarly for this x also, we have this minus 3. And this minus 4 as it is we want. So now calculate all the values. So the value of this expression is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and already this 4, 10, 11, 12, 13. That means 13 times of minus 1, minus 13. So the total value of this expression is minus 13 at the variable x equal to minus 3. Now we will see how to balance algebraic equation. So we have this equation x plus 3 equal to 8. We need to balance this equation. So first we compute this equation in our model. So we have this x slide tiles and we need to compute this 3. So we have this tiles for 1. So 1, 1, 1. Now this makes your x plus 3, which is equals to 8. So 1 plus 1 plus 1 plus 1 plus 1 plus 1, 8 times 1, 1, 2, 3, 4, 5, 6, 7, 8. So this is your equation, x plus 3 equal to 8. Now we need to balance this equation. To balance, we have a positive 3. So we need to add negative 3 on both sides. So this is your negative 1. So 3 times of negative 1 gives you minus 3 on both sides. Now again, this makes your 0 pair. So it vanished from here. This also, and similarly from right side. So now what we have are x equal to 1, 2, 3, 4, 5. X equal to 5. So in this manner we can balance our algebraic equation. Now we are going to find the value of this variable x for this equation 3x minus 1 equal to 5. So first we are going to compute this equation in our model. So we have this x tiles. So first we are going to compute our 3x. So 3 times of x. So this is your 3x and minus 1. So this white side represent minus. So this is positive 1, this is negative 1. So this become your 3x minus 1 equals to 5. That means 5 times we need 1. Now we need to solve this model to find this variable x. So first we need to balance this equation. So we have this minus 1. So if we add plus 1, so they make 0 pair. So we add plus 1 both side. Then this make negative 1 and positive 1, they make 0 pair. So they vanishes from here. So now we have this, if you see on balancing, so you have this. That means your value of x is 2. This side you have 3x and this side you have 6. So for each x you have the value 2. So we will see addition of polynomials. So we are going to add these two polynomial minus 2x plus 3 and x plus 1. So first compute this polynomial minus 2x plus 3. So you have this x tiles. So that means this white side represent your minus x. Minus x, 2 times minus x gives you minus 2x. And now we need to add plus 3. So this is your plus 1, plus 1, plus 1. So this represent your polynomial minus 2x plus 3. So we need to add this polynomial with this polynomial x plus 1. Again you have this x times plus 1. So this is your minus 2x plus 3 plus this polynomial x plus 1. So now this minus x plus x, they give you 0 pair. So they vanishes from here. So only you have this minus x and this plus 4. So that gives you minus x plus 4. So addition of these two polynomial is your minus x plus 4. Now we are going to see subtraction of two polynomials. So we are going to subtract this two polynomial 3x plus 2 x minus 4. So first compute 3x plus 2. You have this x times. So they gives you this 3x tiles gives you 3x plus you need 2. So this becomes your 3x plus 2. Now we need to subtract this polynomial with this polynomial x minus 4. So this is your x times with minus 4. Minus 1, minus 1, minus 1 and minus 1. So this is your 3x plus 2 minus x minus 4. Now this is your negative sign, so they change the sign. So after changing, they become positive of negative x, positive 1 and positive 1. So now if you see this plus x minus x, they make zero pair, so they vanishes from here. So now what you have after adding x, 2x, 1, 2, 3, 4, 5, 6, 2x plus 6. Now we are going to see multiplication of polynomials. So we multiply these two polynomials, x plus 1, x plus 2. We are going to use the method to find the area of rectangle because there is a product of these two lengths. So first we compute x plus 1 length here. So we use this tile, x tile, and this plus 1 tile. So they become x plus 1. So this is a length, this side is of length x plus 1. Similarly, we do for x plus 2. This side we make of the length x plus 2. X plus 1 gives you 2. Okay. So their product gives you area of this rectangle. So we need to fill this area. So we have this length x. So we need to fill x times so if you see they make a square of area x square. So I replace these tiles with this. So this area filled with x square. Also this vacant area we fill with 1x, 1x. So now this is your x square plus 2x. Also this area is vacant, we need to fill it. So this is of unit length. So we need to fill this with 2 times, 3 times, 4 times. And if you see, these 4 are equal to this 1 x tiles. So I'll replace this 4 with now x square x plus x plus x square plus 3x. Also this place are vacant. So we fill this also with 2 1 unit. So now this is your area x square plus x plus x plus 1 1. That is your x square 3 times of x plus 2. So in this way your product of these two polynomials is this area x square 3x plus 2. So now we see division of polynomials. So we are going to divide this polynomial x square plus 5x plus 4 by this polynomial x plus 1. So first we compute this polynomial x square plus 5x plus 4. We have this x square tiles and using this x tiles we make our 5x. So 5 times of this x tile gives you 5x. Also we need plus 4. So using this plus 1 tiles, 4 times of this plus 1 gives you 4. So now it becomes your x square plus 5x plus 4. So that this polynomial is divided by this polynomial x plus 1. So that means this x plus 1 represent you one side of this rectangle whose area is x square plus 5x plus 4. So we compute this x plus 1 with this x n plus 1 time. So first we need to make uniform rectangle. So, and we need to find the another side of this rectangle. So this is of unit length. So this is we complete with the unit length. Tiles. We fill the thing. So if you see this 4 gives you this x tile. And also this represent your square of area x square. That means their all side are x. So instead of taking this 4, we are using this x tiles here. For this x square. For this square of area x square. And we'll manage this 4, 1 here. Now this gives you this rectangle whose one side is x plus 1 and another one is x plus 1 plus 2. 1, 1, 1 gives you 4, x plus 4. Now we are going to prove some algebraic identity. So this is very familiar. X plus y the whole square is equal to x square plus 2xy plus y square. So we are going to prove this identity with our models. So we'll take this x plus y square as x plus y product x plus y. As we do earlier, we are going to compute as area of rectangle with the length x plus y, x plus y. So first we make one side x plus y. For that we have this style x and y. They make your x plus y. So this is a side of length x plus y. Similarly, we make another side x plus y. This is your x and y. So now we need to find this area whose length are x plus y. So first we compute this portion. We fill this area with this style x. So this is actually gives you the square whose length is x. So instead of this, we are going to use this type. So this gives you, this square give you x square. Now again, we need to fill this area also. So this is of side x. So again, we fill with this x tile. See how many tiles we need. 2, 3, because we need to compute this side and this side. So this gives you this rectangle whose one side is y and one side is x. So this is a area. This gives you area xy. So instead of this, we have this type. So I'll replace this with this. So this represent you the rectangle of area xy. Again, we need to compute this. If you see this is of length y, so fill this with y tiles. And this side is your so if you see this side is your x and this side is your y. So this give you the rectangle of area xy with one side x and one side y. Again, we replace this with this xy tiles. If you see is one length is x, one length is y. Now this length is your y. Again, compute this area. So this gives you, now if you see both the sides are y, so this gives you square of area y square. That means the total area of the total rectangle is x square plus xy plus x5 plus y square. That means x square plus 2 times of x5 plus y square. Similarly, we are going to prove this identity. X minus y square is equal to x square minus 2xy plus y square. Again, we take product of these two polynomial x minus y into x minus y. So we are going to compute our square whose length is x minus y. So this is your x time and this is your y time. So if this is your y time, that give you your minus y time. So x minus 5. This side gives you x minus 5. Similarly, for this side also x. This is your y, so this is your negative y. X minus 5. Now we have this square whose sides are x minus y. That means we need to compute this area because the square of this side gives you the area of this square. So first we are going to fill this area with this x times because this length is also x and up to this length. So this gives you x square. Now again, we need to compute this area. But if you see, this one side is your x, but the another one you have minus y. And if you know the product rule, positive product negative always give you negative. So instead of taking x into y, we have x into minus y is minus xy. So this gives you negative. We fill this minus y times. So this gives you xy. So this is your minus xy. Similarly, this one side is your negative and another one is positive. So they give you negative xy. So fill this with y tiles. And one side is your x. So again, this become a rectangle whose one side is x and one side is minus y. So this is your minus xy instead of xy. And if you know in product negative give you positive. So your one side is minus y and another side is also minus y. So they give you positive product. So that's why fill with color sign. This is of y length. This is also of y length. So this give you square whose area is y square. So now add all these areas. So they give you the total area of this square. So this is your x square. This is minus xy plus y square. So they give you x square minus 2xy plus y square. So this represent you the square whose side is x minus y. So their area is x minus y square, which is equal to x square minus xy minus xy. They gives you minus 2 times of xy plus y square.
धन्यवाद सभी को। और जैसे कि इस पूरे डिमॉन्स्ट्रेशन में मैंने इंग्लिश में ही बोला है, तो यहाँ कुछ बच्चों के लिए मैं हिंदी में थोड़ा बहुत एक्सप्लेन करूंगी। यहाँ जो भी मॉडल्स आपने देखे, जैसे बीजगणित के जो भी समीकरण होते हैं, उनको सॉल्व करने के लिए हम ज्योमेट्री को यूज कर सकते हैं। जैसे पिछले मॉडल में आपने देखा था, अनिरुद्ध ने आपको समझाया कि रेक्टेंगल का एरिया कैसे फाइंड करते हैं। तो उन सबको हम यूज करके, जैसे कि ये एक आयत है हमारे पास, ठीक है, तो उसकी एक साइड को, एक लंबाई को हमने x वेरिएबल जो आपका चर होता है, एक को y, ऐसे लेकर उनके एरिया को यूज करके हमने अपने वेरिएबल फॉर्म किए हैं। जैसे कि इसमें आपने देखा यहाँ पे ये लेंथ जो है आपकी, एक लंबाई, ये चौड़ाई है, उसकी हमने x ले ली और ये लंबाई y ले ली। तो इसका आपको पता होगा कि जो आयत का क्षेत्रफल होता है वो लंबाई गुना चौड़ाई होता है। तो ये इससे आपका क्षेत्रफल मिल गया xy। इसी तरह ये हमारा वर्ग था, जिसकी एक भुजा हमारी x थी, तो उससे हमने x स्क्वायर बना लिया। तो इसी तरीके से इस छोटे छोटे आयत को और वर्ग को यूज कर करके, मतलब ज्योमेट्री को यूज कर करके, इन मॉडल से हम अपने बीजगणित के समीकरण सॉल्व कर सकते हैं, जो बहुत ही रोमांचित तरीके से आप अपने बीजगणित के समीकरणों को, इक्वेशंस को, और जो आपके इम्पोर्टेंट कुछ फॉर्मूलेज होते हैं, जैसे कि x प्लस वाई का होल स्क्वायर, x प्लस वाई का वर्ग, तो उस तरीके के समीकरण आप इन सभी छोटे छोटे ज्योमेट्रिक मॉडल्स को यूज करके कर सकते हैं।
Thank you, Sheetal. It was really an interesting demonstration. I hope everyone by now are able to visualize their theoretical knowledge. So let us give all a round of applause for Sheetal.
Thank you.
Okay, so next we have with us Mr. Sahil Kalra, a PhD student in our department, who is going to explain to us about the locus using the GeoGebra. So the screen is all yours, Sahil.
Hello everyone, I am Sahil, PhD student of IIT Indore. So today I'm going to discuss about locus and we'll demonstrate it using GeoGebra. So first of all, we will look at the what is definition of locus. What is locus? So in geometry, locus is nothing but a set of all points which satisfies some rule. In other words, locus is nothing but the path followed by a moving point which satisfies some conditions. For example, if we are walking in a garden or we are following a track, then the path which will be followed by our footsteps is the locus of our feet. In geometry, the curves like lines, circles, parabola, ellipse, etc. are nothing but a locus of one or more points which satisfy some criteria. Okay, so we will use GeoGebra for its demonstration. Okay. So what is a line? A line is nothing but a locus of a point which is equidistant from two given points. Let us look at it using GeoGebra. Okay. First of all, what we will do, we will fix 2 points A and B. Okay. So now what we want to do, we want to collect all those points which are equidistant from these 2 points A and B. For that, what we require a circle. Okay. Okay, for that, I am drawing a circle around A and B of radius A, where A is what? A is ranging from 0 to 10. With time, my radius will increase according to as my A will increase. Okay, so after that, I am trying to intersect two circles, take the intersection points, which are C and D, which you can see here. After that, I am going to trace these points C and D. Okay, so remember that C and D are nothing but those points which are equidistant from A and B. So now we want to trace these points C and D. Now we will want to see what these points C and D will trace, which you can see clearly that they are tracing a line, a straight line. So it means any point which is equidistant from two given point will trace a straight line. So now we will go to another example, which is a circle. So now we'll look at what is a circle. A circle is a locus of a point which is at a fixed distance from a given point. And that fixed distance we call it as the radius of the circle. Okay. So now let us take a point A and draw a line segment from A of length 3, say. And now we want to see what this point B, which is the end point of this segment, traces out. So now if we try to trace this point B, we can see that it traces out a circle, which you can see in this video. Okay, so it means what? It means any point which is at a fixed distance from a given point traces out a circle. So ellipse. Ellipse is the locus of a point, sum of whose distances from given two points remains constant. Okay, so to demonstrate this, what we require? We require 2 points, say A and B. Also, we require a point C, say, such that the sum of whose distances from these 2 points A and B remains constant. So how we will collect those points? What we will do? We will draw a circle, say of radius A, small a, around A. Also, suppose that if we want the constant distance to be 5, what we will do for that? We will draw another circle around B of radius 5 minus A. Now, if we intersect these two circles, the intersection point will satisfy the property that these points will give us the constant, the sum of distances will be constant. Okay, so now we will want to trace these 2 points, C and D. Again, also you can see that the distance D and DB, if that is the sum of these two distances is 5. Okay, so now if we try to trace these 2 points C and D, we can easily see that these 2 points C and D are actually tracing out an ellipse, which you can easily see in this video. And the points A and B are nothing but the foci of the ellipse. So now we'll move to the case of parabola. Okay. So parabola is the locus of a point which is equidistant from a given point and a given line. The given point we name as focal point and given line we name as directrix. To demonstrate parabola, we require a point which is a focal point which we're naming as A, which is 0, 1. So since the focal point is at 0, 1, so the equation of directrix is given by y is equals to minus. Okay, so now let us choose a random point, say D, on this line of directrix. Now, what we will do, we will draw a perpendicular line passing through this point D. Now, drawing a line segment between A and D, take a perpendicular bisector of this line segment AD. Wherever this perpendicular bisector will cut the perpendicular line passing through D, will give us a point. And this point is satisfying the property that the distance of this point to A and to point D will be same, which you can see, which is 2.18 in our case. Now we'll try to trace this point E. So if we try to trace this point E, it will give us parabola, which you can easily see in this video. Also, the vertex of this Parabola is nothing but 0, 0, and focal point is 0, 1, and equation of directrix is y is equals to -1.
ओके, सबसे पहले धन्यवाद सभी को मेरी वीडियो देखने के लिए। तो ठीक है, मैं कोशिश करूंगा कि इसको हिंदी में समझाने की कोशिश करूं। तो सबसे पहले लोकस है क्या? लोकस मतलब कि अगर मेरे पास कोई एक पॉइंट है, तो मैं अगर उस पॉइंट पर कुछ कंडीशन लगा रहा हूं, तो वो उस कंडीशन के अंदर किस आकार में घूम रहा है, वो आकार, वो जो पाथ है, वो जो रास्ता है, वो जो उसने उस पॉइंट ने फॉलो किया है, उसको मैं लोकस कहूंगा। जो बहुत फेमस कर्व जैसे लाइन हो गया, सर्कल हो गया, पैराबोला हो गया या एलिप्स हो गया, ये सब क्या है? ये सब लोकस हैं किसी एक पॉइंट के, जो कुछ एक या एक से ज्यादा पॉइंट्स के जो कोई कंडीशंस को सेटिस्फाई कर रहे हैं। जैसे कि अब हमने देखा लाइन के एग्जांपल में, लाइन क्या है कि अगर मैं दो बिंदु या 2 पॉइंट फिक्स कर रहा हूं, उसमें एक पॉइंट ऐसा लिया, सपोज एट द मिड पॉइंट और एट ऐसा एक पॉइंट लिया जिसका डिस्टेंस ए से और बी से सेम है, और अगर मैं इसको ट्रेस करूंगा, इस पॉइंट के को मैं ट्रेस करना चाहूंगा, तो वो जो पॉइंट है जैसे जो है वो एक लाइन के रास्ते में मूव करेगा। सिमिलरली हमने देखा सर्कल के लिए क्या किया, हमने एक पॉइंट फिक्स किया और दूसरा पॉइंट हमने लिया जो इससे एक पर्टिकुलर डिस्टेंस से 3 यूनिट के डिस्टेंस पर है। तो जब मैं इस पॉइंट को मूव करूंगा, इस तरह से मैं मूव करूंगा कि इसका डिस्टेंस जो है वो मेंटेन रहे, इसका डिस्टेंस जो 3 यूनिट मैंने लिया है वो चेंज ना हो। तो वो किस रास्ते को फॉलो करेगा? वो एक सर्कल के रास्ते को फॉलो करेगा। तो हमें जो उस पॉइंट का लोकस होगा वो एक सर्कल होगा। इसी तरह हमने देखा एलिप्स क्या है। एलिप्स में हमने क्या किया कि हमने 2 पॉइंट फिक्स किए और एक ऐसा पॉइंट फिक्स किया कि उस पॉइंट का वो 2 फिक्स पॉइंट से जो डिस्टेंस का सम है वो कांस्टेंट रहेगा। अगर इस कंडीशन के अंदर मैं अपने पॉइंट को मूव करवाऊंगा, तो वो जो पॉइंट जो एक रास्ता फॉलो करेगा वो और कुछ नहीं, वो एक एलिप्स होगा। और वो जो 2 पॉइंट हमने फिक्स किए थे पहले, वो और कुछ नहीं, वो फोकाई होंगे एलिप्स के। इसी तरह हमने पैराबोला का केस लिया। पैराबोला में हमें एक लाइन चाहिए होती है और एक पॉइंट चाहिए होता है। तो उस पॉइंट को मैं बाद में फोकाई बोलता हूं और उस लाइन को मैं डायरेक्ट्रिक्स बोलूंगा। अब इस लाइन का और इस पॉइंट का किसी एक पॉइंट से अगर डिस्टेंस मैं सेम रख रहा हूं और उस पॉइंट को अगर मैं मूव करवा रहा हूं, तो मैं देखूंगा कि ये जो रास्ता उस पॉइंट ने फॉलो किया है वो और कुछ नहीं, वो एक पैराबोला होगा। तो इस तरह मैंने जियोजेब्रा की मदद से लोकस को समझाने की कोशिश की। आशा करता हूं कि आप सबको समझ आया होगा। थैंक यू।
Thank you, Sahil. Bhaiya. It was such a wonderful demonstration using GeoGebra. I'm so sure that all the people watching this are going to apply this knowledge of GeoGebra and use it in their studies. So, in the next, we have Mr. K. Divya Prabhu, who is also a PhD student in our Department of Mathematics, who is he is going to demonstrate us on Hilbert's infinite hotel. So, the screen is all yours.
I'm Divya Prabhu, doing PhD at the Department of Mathematics, IIT Indore, under Dr. Anthony, which is Dr. Sanjeev Singh. So now in this video, I'm going to talk about power of infinity by using Hilbert's total problem. So what is infinity? People may think that infinity is never ends. So as for example, natural numbers, 1, 2, 3, 4, etc. It is keep on going. So there are many infinities, but now in this video, we are going to see that infinity produced by natural number and see some important properties of these infinities. Let us go for the video. In this video, we are going to look at power of infinity by Hilbert's infinite hotel problem. So assume this is in Hilbert's hotel. This has infinitely many rooms. Every room is, we associate natural numbers to every room. This is room number 1, this is room number 2, this is room number 3, and so on. So he is manager, he is very happy because this hotel is completely full. In every room there are people. There is no vacant room available in this hotel. These are our assumptions. So now the problem comes. One visitor came suddenly and he has one room. Now because of some technical issues, manager has to give room to this person, but he is thinking very hardly. He don't know what to do. So now he is thinking, and then he solved this problem by using mathematics. First, he made an announcement to all the people living in the hotel to change their room to their next room. That means people living in first room has to shift to second room. People living in second room has to shift to third room, and so on. So this process will keep on going. So this is the general process that people living in nth room has to shift to n plus 1 room. So what is the use in this process? The use is there is no people live in first room because he has already shifted to second room. So the first room is vacant. So the manager is very happy because he can associate that visitor to this room. So now in second day he again faces one more problem, that a group of 100 people now came. They all need rooms. Because of the same technical problem, he has to give rooms. But what he has to do? He thinks and he again uses mathematics to resolve this problem. So now he again made an announcement that people living in hotel has to change room, but now their new room numbers are allocated by in this fashion. That if that people's new room number is 100 plus their old room numbers. That means people living in first room has to go to 101st room. Second room has to go to 102nd room. Third room has to go to 103rd room. In this process will also keep on doing. So, but the fruitful thing in this process is this first 100 rooms will be vacant now. So he can associate those 100 people to these rooms. So now this problem is also resolved. So now one more thing. This is an infinite. This is called as infinity bus. The problem in this bus is this bus has infinitely many seats, and there is a numbering in the seat. The first seat numbered as 1, 2, 3, and so on. This is an infinite bus. It has infinitely many seats. Now the third problem is these bus come to this hotel and everybody is asking room. This bus is completely filled. There are infinitely many people in this bus. They all are asking rooms. Now the manager is thinking, and he has to solve the problem. He has to associate rooms to all the people, but he don't know how to do it. Again, he has to use mathematics to resolve this problem. So now, before giving them rooms, he has to vacant some rooms for them. So that process he has to do. For that, he is going to make an announcement that people has to change. People living in the hotel has to change their rooms, but their new room number is 2 power the old room number. That this is the mapping. That people living in nth room has to shift to 2 power nth room. In simple case, people living in first room has to shift to second room. People living in second room has to shift to fourth room. People living in third room has to shift to 2 power 3, which is 8. People living in fourth room has to shift to 2 power 4, that is 16. People living in fifth room has to shift to 2 power 5, that is 32, and so on. And what is the use of this process? This is the use. Because now all odd rooms are vacant. Because anyway people are going to shift, and their room numbers that they are going to shift are all powers of 2. So 2, 4, 8, 16, 32, and so on. Powers of 2 all are filled, and all the remaining rest of rooms are vacant. So here obviously 14 is also vacant, but the key observation is all odd rooms are vacant. So now what he will do? He has to make one more announcement to the people in the infinite bus. He says that you have to go to the room number which is defined in this fashion. If people sitting in first seat has to go to 2 into 1 plus 1, that is third room number. In that way, this is the pattern that people sitting in bus has to go to this number room, 2 into bus seats number plus 1. So this is the general pattern. People sitting in nth seat has to move to 2n plus 1 room. So the fourth problem is similar to this. There are infinitely many infinite buses. So now they all are parked in this fashion. 1, 2, 3, 4, 5, 6. There is a numbering. This number goes to infinity. Now they all are wants. This all infinite buses are filled. They all want room. Now the manager is in serious trouble. He has to associate room to all this person, but he don't know how to do it. So now he found out the way by using mathematics that first he has to vacant some rooms for these people that he knows by the previous. That he made an announcement that people in the hotel has to change their room, and their new room number is 2 power the old room number. So this is the general pattern. People living in nth room has to go to 2 power nth room. So in that fashion, the people living in first room has to go to 2. People living in second room has to go to 4, and so on. So after this process, these all rooms are vacant. These blue rooms are vacant. These red rooms are filled. So these many rooms are vacant. Now you may think that what we will do, all odd numbers are vacant. Then the immediate natural answer is for the first infinite bus, we have to associate them to all odd numbers. That means we have to give a mapping n goes to 2n plus 1. But there is a problem that it is very difficult to find out the pattern for the rest buses. So we are going to use different idea here. What is the idea that we are going to use is as follows. So this is the people. Assume that this is the people all in bus 1. So we are going to define a mapping that in the bus 1 there is a seating plan. So the mapping is people sitting in first seat has to go to 3 power 1. Second seat has to go to 3 power 2. In general, people sitting in nth seat has to go to 3 power n. So this is the general mapping. This is their room number. 3 power their seats number. So this is for second bus. People sitting in second bus has to go to 5 power their seat number. So what is the natural idea for the third bus? It is 7 power their seat number and so on. So these 3, 5, 7 and in general in the nth bus people has to move to nth power their seat number. So this is the general pattern we are going to follow. This 3, 5, 7 and these are all prime numbers. So in this way, we resolved all this problem. But in this resolution, we have to thank one person, that is whose name is Euclid, because he proved that there are infinitely many primes. Because of that reason only, we can associate for every bus, we associate a prime number. So we use this theorem. And then there one more theorem we used, that because suppose if there is, it may happen that 3 power n and 5 power m may be equal. But because of this theorem, fundamental theorem of arithmetic, it says that if natural number has unit prime factorization. So because of the theorem, 3 power n is equal to 5 power m, if and only if there is no chance that 3 power n will be equal to 5 power m. So in this fashion, we resolve this problem. Thank you.
Hello. Hello. Your mic is mute.
ओके maybe I can explain. मैं समझा सकता हूँ क्योंकि प्रभु शायद हिंदी थोड़ा प्रॉब्लम।
ओके।
तो प्रभु ने इस वीडियो के थ्रू ये समझाने की कोशिश की है कि इन्फिनिटी की पावर को समझाने की कोशिश की है, इन्फिनिटी का एसेंस समझाने की कोशिश की है कि इन्फिनिटी का कोई एक ऐसा नंबर नहीं है जिस तक हम पहुंच सकते हैं, या इन्फिनिटी का कोई अंत नहीं है। इसलिए इसमें ये दिखाया गया है कि एक हिल्बर्ट होटल के प्रॉब्लम को दर्शाया गया, जिसमें ये बताया गया कि एक होटल का मैनेजर जो सभी रूम भरे होने के बावजूद भी सीमित मात्रा में आए लोगों के लिए ही नहीं बल्कि असंख्य अनगिनत आए लोगों के लिए भी होटल का रूम उपलब्ध करवा पाया। ऐसा क्यों हुआ? क्योंकि इन्फिनिटी का कोई अंत नहीं है। तो उसमें कोई अगर हम रूल के हिसाब से अगर हम रूम वेकेंट करवा पाए और या फिर हम अपने भरे हुए रूम को शिफ्ट कर पाए, उसमें रहने वाले लोगों को किसी और आगे जाने वाले रूम्स में शिफ्ट करवा पाए, तो बीच में बचे हुए रूम या जो पहले बचे हुए रूम है उसमें नए आए लोगों को भी रूम दिया जा सकता है। ये इसलिए हो पाया क्योंकि इन्फिनिटी का कोई अंत हमारे पास नहीं है। तो इस प्रॉब्लम को सोल्व करने में हमारी दो इंपॉर्टेंट थ्योरम्स ने हेल्प करी। पहली थ्योरम क्या थी कि हमारे पास असंख्य प्राइम नंबर्स है। दूसरी क्या थी कि हर नेचुरल नंबर के लिए हमारे पास एक और केवल एक ही फैक्टराइजेशन उपलब्ध है प्राइम नंबर्स की फॉर्म में। तो इस तरह से हमने जो वो होटल का मैनेजर है उसने इस हिल्बर्ट होटल प्रॉब्लम को सोल्व किया और इन्फिनिटी के एसेंस को दिखाया।
Thank you, Mr. Divya Prabhu, for this wonderful demonstration. I would like to ask everybody to give a big round of applause for Divya Prabhu. And also Mr. Sahil for his wonderful explanation on GeoGebra, as well as the explanation in Hindi about this Hilbert's Infinite Hotel. So I like to clap. I would like everybody to clap or give a big round of applause given for. So I hope. Hello. So I hope. Hello.
Yes,
Yeah.
Manasa, you're audible. Yes.
Okay, so I hope everybody have enjoyed this session and participated. I would like to, now it's a time that we express our gratitude to the program. So now First of all, I would like to thank the IIT Indore and the Department of Mathematics for providing us this opportunity to celebrate the National Science Day in a very beautiful manner. And also, I would like to thank the HOD of our department who have provided and given us the whole support for this program and made this program a very nice and a successful thing. So along with that, I would also like to thank the outreach committee and the seminar committee of the Department of Mathematics who have given us the whole support to conduct this program and arrange this program very cleanly. And also, I would like to thank Dr. Shantanu Manna, the coordinator of this program, who have supported and encouraged us to give this program a very nice beginning. And last but not the least, I would also like to give a special thanks to the people like Meghali, Archit, and Swaroop, the PhD students of our department who have helped us for all the recordings of these sessions. And also, I would also like to thank Mr. Sahil for the poster making of this program. So, last but not the least, it is our duty to thank all the viewers who have come here, who have watched our program and made this program a very successful one. Thank you, everybody. So the session is concluded. So please, you can leave the program.